Hello, I'm Greg. Welcome to my channel, Midnight Oil Software. In this video, I'm going to teach you how to implement an orbiting companionship like you see in this video here. So, grab your favorite beverage, pull up a chair, and follow along as I teach you how to create an orbiting companionship in Unity. This video is actually a command performance. A viewer named Roy was commenting on one of my Defender tutorial videos, and he asked if I could do a quick tutorial on a power-up system where the power-up circles the player, like in this example. And he provided a link to this video here, a game called Armalyte. And if you look at the video, you can see that there is a companion ship that is orbiting the player ship. And you look at the video description here, and you can see that the original game that it's based on had this concept. And I looked at this and I thought that looked like a pretty interesting concept and something that would be fun to implement. And so I've decided that I would go ahead and make a tutorial showing how I would implement this. And I've never done anything quite like this before, so this is my initial attempt at how I would implement a orbiting companion ship around the player ship. So the very first thing we need to do, of course, is create a new Unity project. So I'm going to assume that you've already created a Unity account. They are free, by the way, and that you've downloaded and installed Unity Hub. I will put links in the description if you haven't done that already. But once you've done that and you've opened up Unity Hub, you come into here and you click New Project. And I'm going to select the 2D URP template, because this is going to be a 2D game using the universal render pipeline. And I'm going to put this in my tutorials folder, and I'm going to call this Orbiting Companion Ship. And I will click Create Project, and this is going to take a while. So I will pause the video, and I will come back when this is done creating the project and opening up in Unity. Okay, we're back, and it has successfully created the Unity project and opened up the Unity editor. This is a blank Unity project. If you're not familiar with it, you've got your hierarchy over here. These are the objects in the current scene. Down here we've got our project structure. So we have our assets folder. Under there we've got our scenes, and right now we just have the one scene. It's the sample scene that we have open here. And then there is a folder for settings. Now, one thing I like to do, you'll see this little slider here. I'm just going to slide this all the way down so we see the names without the icons. And then I'm going to create a new folder in here, and I'm going to call this Art. And we're going to import some art assets. So I'm going to double click that. Now, I like to get my art assets for my tutorials from a site called itch.io. It's a great place to find some free assets. So I basically went to itch.io and I said Browse, Assets, and then I selected Sprites and Free. And so this is a list of a bunch of free sprite assets that you can download and import into your project. So I actually found a couple that I like. There's the Seamless Space Backgrounds package. You can see there's some nice nebulas and star fields and stuff. And there's this Game Creators pack that has some ships that I think would be cool to use in this project. So I've already downloaded them. To download them, you would just say click Download Now and say if you don't want to donate anything, you can say take me to the downloads, and then you can download the pack that you want to get. And I just got this one up here, and I did the same thing for the Seamless Space Backgrounds. I just grabbed this RAR file here with the large backgrounds. So what we're going to do is we are going to import those into our project. I downloaded them as a zip file and a RAR file, and I have those open here. So first of all, let's start with the Seamless Space Backgrounds. So you can see it is a RAR file, which is a type of a compressed file like a zip. I'm using 7-zip. You might have to download some app for your operating system that can open RAR files. I'm using 7-zip. It's free. But I'm going to go into the large 1024 by 1024 folder under Blue Nebula, and I'm going to take this Blue Nebula 2, and I'm just going to drag this into our art folder. So now if I select this, I want to change the sprite mode from from the mesh type from tight to full rect. And I want to change the wrap mode from clamp to repeat. And what this is going to do is it's going to let us tile this so I can stretch it. And instead of it just stretching the image, well, let me show you what I mean. I'm going to put this back to clamp and tight. I'm going to drag this image. I'm going to create an empty game object here and call it background. And I'm going to drag that image onto our background. And now if I just stretch it, you can see that it's stretching the image, and that looks kind of weird. Now what I want is I want a tileable image, and since this image is seamless, I can tile them right next to each other, and it'll look like you're just flying across a big body of space, and these nebulas will float by. So to make that work, we change it from simple to tiled. But in order for that to work, we need to go back to here, and we need to say full rect, repeat, apply, and then in here, that warning went away that we were seeing. And then if we were to just stretch this, now you can see that it's actually just tiling it, which looks a lot better than just stretch. And then I'm going to make this a little bit taller, and I'm going to change our game view to be full HD, 1920 by 1080. So there you go. Now we're going to actually scroll this using a script. So I'm going to go back to our assets folder. I'm going to right click, create folder, and I'm going to call this scripts. Double click that, and I'm going to right click, create C# script, and I'm going to call this background scroller. And Unity's going to think for a second. It's got to compile that script. And when it's done, I'm going to drag it onto this nebula. So there, I select the nebula in my hierarchy. I drag the script over there, and there we go. And if I double click on this, or if I double click on this, either one will open up the editor. In my case, I'm using JetBrains Rider. You're probably using Visual Studio or Visual Studio Code. Either way, you want to open it up. And I'm going to drag this window over here and collapse this and zoom in so you can see what I'm doing. Now I'm going to point out something here. Your file is probably going to look different from mine. I edited my script template so that it deletes some extra boilerplate code that Unity always adds when you create a new script. And I also added this code here to cache my transform. I do this for performance reasons, and I have a whole video on a debate that I had about whether there's any benefit to doing that. We don't need it for this script, so I'm going to delete it. The one thing I'm going to do is create a serialized field. So a serialized field is basically a field that is exposed in the Unity editor, so we can change the value in the editor. And I'm going to call this scroll speed. And I'm going to give it a default value of 2, and it needs to be a float. So there, that all looks good. So we have a float of 2 assigned to this named scroll speed, and it is a serialized field so we can see it in the editor. And I'll demonstrate that by jumping back out to the Unity editor. And you can see scroll speed with a value of 2. And then we can change this in the editor if we want to. And we probably will play with that value because this is just a ballpark estimate. This is going to be how fast the background scrolls by. So I'm going to open this back up, and we're going to implement the scrolling. The first thing I want to do is I'm going to add an awake method. Now, awake is a method that's called automatically by Unity. If we hover over this, you can see it's called when an enabled script instance is being loaded. So what we want to do when this script is being loaded is we want to get our renderer that is on this component. So this scroller is sitting on that sprite component, and that sprite has a renderer. Specifically, it has a sprite renderer. And so I'm going to use a function called getComponent. GetComponent, and we want this one that has the open and close brackets here, or less than greater than sign, and we're going to specify renderer as the type of object that we're looking for. And what this will do is it will look on the component that this script is attached to and try to find a renderer on it. And if it finds it, it will return it and assign it to this variable. And I need to define this variable. So I'm going to put my cursor there and hit Alt-Enter and say create field. And there it created that field there. So now we have a reference to our renderer that we're going to use to scroll that background. So we're going to add another method here called update. And if we hover over this, you'll see that update is called every frame. So when this script is enabled, Unity is going to call this function every single frame. So if your game is running 60 frames a second, this function will get called 60 times a second. And in here is where we're going to want to do the scrolling. And the way we're going to do it is we're going to get the texture offset from the material that's on this component. And we're just going to change that offset on the x-axis. So we're only scrolling horizontally here. So let's first of all get our current offset. And that is stored as a vector 2. So a vector 2 just has an x and a y. So we'll call this current texture offset. And we're going to grab it off our renderer's material using the get texture offset function. Now you give this a string, or you could give it a property index. We're going to give it a string initially, and I'm going to show you a neat little trick here. So the property that we want is the main text property, and it's got to have this little underscore in front of it. Now you see this little yellow squiggly line. My editor, Rider, is telling me that string-based property lookups are inefficient. And it's especially inefficient if you're doing it in update, which is called every, single frame. So what we're going to do is we're going to let Rider fix this. I'm going to select this little light bulb here and say use cached property index. And you see it created this static read-only field called main text, and it used the shader's property to ID function to convert that main text string to an integer. And now that's what I'm passing in to get texture offset, and that will be faster than basically doing this lookup every single frame. All right, so now we have our current texture offset, and let's figure out how far we want to scroll. And the way we're going to do that is we're going to create a variable called distance to scroll. And we're going to calculate that by using something called time.delta-time. So time.delta-time is basically the interval that's elapsed since the last frame was called. So what we want to do is smoothly scroll it no matter what your frame rate is. So it'll look the same on a really fast machine as it will on a slower machine. And that's what we use time.delta-time for. And we're going to multiply that times our scroll speed. So this will tell us how far we want to scroll this texture. Now we're going to calculate the new offset. So we have our current offset. Let's calculate our new offset. So we're going to call this new x offset because we're only scrolling in the x direction. And we're going to take our current offset's x position, and we're going to add that distance to scroll value. And then we're going to put that into a vector 2, because that's how the offset is stored. And we're going to set that to be a new vector 2. We're going to use that new x offset value, and then we're going to use the current texture's y value. So we're only changing the x offset, and we're going to assign that back to our renderer's material. So we'll say renderer.material set texture offset, and we're going to pass in that same property index that we cached up here, and we're going to pass in our new offset. Now if we jump back out into Unity and we give that a quick test, we should see this background start to scroll by. And there it goes, and that's really, really fast. So let's play with this value a little bit. I think something like that looks pretty good. So maybe 0.75. So we'll stop that. And you'll notice when I stop playing, this is going to go back to the original value. Right? So the reason my screen turned blue when I hit play, so watch this again, all of this stuff turned blue. Why is that? Well, that's because I set a setting under preferences. under colors, play mode tint. I set this so that when I hit play, it will change the color of my interface to let me know I'm in play mode. Because if you're in play mode and you make a change to a value in the inspector like this, you lose those changes when you stop playing. So this little play mode tint tells me, hey, you're in play mode. Make sure that you exit play mode before you make changes if you want them to be saved. All right. So I will stop playing and I will set this to 0.75 and I will hit play. And it should be scrolling by at that slower speed that we want it. And there we go. So we got a nice scrolling background. Okay, let's go ahead and import the art for the ship and maybe one of the enemies. So we're in our art folder under assets. I'm going to drag in the zip file that I downloaded from itch.io from the game creators pack. And let's take a look at this under graphic pack. I think I'm going to want the shooter boss sprite. So I'll drag that in here. Now, by the way, I'm using 7-zip again, and it lets me drag from here into the project. If you're just opening this up as a compressed folder in Windows, it will not let you drag to here like this. What you would have to do instead is right-click and say Show in Explorer, and then go in there, and then you could drag the files that way. I'm going to also drag in a shooter sprite sheet. So let me bring this over here. Shooter sprite sheet. Let's go back into Unity here, and as you see, it imported that shooter boss sprite and shooter sprite sheet. Now, if we look at this, this is not exactly what we want. This is right now just showing us one big image. So what we want to do is slice this up so that we can access these individual sprites. So the way we do that is over here where it says sprite mode, we want to change that to multiple and hit apply. And then we want to go into the sprite editor and we want to hit slice and say automatic and then click slice. And now if you look at this, you can see we've got these little rectangles around all of these individual images. So if we go ahead and click apply, now if you look down here, you can see that this sprite sheet is split up into all these individual images. And this slider here again will let you change your view. So if you want to see the actual sprites that way, you can just slide that thing up. And there we go. So I think a good sprite for our shooter would be this guy right here. We can maybe use that for the main player ship, and then maybe use this guy for our orbiting ship. So let's come up here and create a new empty game object and call this player. And then I'm just going to drag sprite 0 onto there. And one thing I want to do is I want to create some layers here. So I'm going to go up to background. I'm going to say add layer, and I'm going to call this background. Go back into here and then assign this to the background layer. Say yes, apply it to children. And now this guy, I'm going to say add layer, player. And while I'm in here, I'm going to say player companion. And then maybe I'll say player projectiles and companion projectiles. Put everything on their own layer. So this guy will be assigned to the player layer. And then what we're going to want to do in here is set his order and layer to be 1. And now you can see he's on top of the background. And that looks pretty darn small. So what I'm going to do is I'm going to go into our sprite here. And where it says pixels per unit, let's change this to 50 and hit apply. And there you can see it doubled it in size. that's probably pretty good. I think I'm also going to come in here and just increase the scale. That looks a little bit better. And I'm going to rotate this guy. I think I want to rotate it around the Z-axis. Yep. So now he's facing forward. So the object himself, the player object, if we look at him in the scene, this is going to be right. And that's going to be our forward, basically, is right is that way. And then let me turn off our gizmo so you can see him better. So even though I had to rotate the sprite 90 degrees, this is going to be forward as far as this player is concerned. So if we hit play right now, this player should stay here, but it should look like he's flying because the background is scrolling past. And there it is. So let's get him moving around based on player input. And because I'm going to reference this input from both the shooter, or the player I should say, and the orbiting companionship, I'm going to create something I'm going to call input configuration. So I'll just create an empty game object here, call it input configuration. And by the way, I want to organize things a little bit. So I've got this main camera here. I'm going to right click, create empty, and I'm going to call this camera and light. And I'm going to drag the camera and the light into there. And I'm just going to move that all the way up to the top and collapse it. And I'm going to collapse our background. And I'm going to move this input configuration up under camera and light. And we're going to create a new script here in our scripts folder. And I will call this input configuration. Let Unity think about that, and then I will drag it onto that input configuration object. And there it is. Double click to open that up in the editor, and we'll zoom in. And I don't need any of this stuff. So basically all our input configuration is going to do is it's going to define the keys for forward, back, up, and down. And we're going to do that through serialized fields. So I'm going to say serialized field, key code, forward, and I'm going to default that to key code D. And I'm going to do the same thing for back, up, and down. And so if forward is D, then back will be A, and then up will be W, and then down will be S. So ASWD, typical keyboard controls. And then I want to expose these publicly. So I'll have public key code forward, and this is what's called an expression body method. Basically, it is a public property that just returns this value here. And we'll do the same thing for back, up, down, back, up, down. All right, there's our input configuration. Go ahead and close that. We're going to create a new script that's going to be our player mover. And we're going to add that to our player, and that's what's going to handle moving the player ship. So down here in scripts, right click, create, C# script, player movement. And I'll select our player, wait for Unity to recompile that. And I will drag that onto our player. And double click to open it up in the editor. Zoom in. And this time I'm going to keep my cached transform. But I'm going to add a couple of serialized fields up at the top here. First of all, I want to have our start position. And I want to have a move limit to how far we can move away from that start position. And I'm going to default that to 2 units. And a move speed, which I'm going to default to 5. Let's make it 10. Okay. And we're going to want our input configuration. So one of the things we're going to do in awake is we're going to say that input config equals find object of type. Now this time we're not using get component because input configuration doesn't live on this component. We need to go find it in the scene. And we're only doing this once when this script first wakes up. So we're looking for input configuration. And I'm going to give this a value of true. So this will load it even if it's not enabled yet. And then we will hit Alt-Enter, create field. And there we go. So now we've got our input configuration. So what I want to do now is actually handle the movement. And we'll start with something simple first, just moving forward. So we're in our update method. We're going to say if input.getKey, and we're going to use our input configurations up value. So if we're pressing up and our transform.position.y, so I guess I'm moving up, not forward. So if our y is less than our start position dot y plus our move limit, then we want to say transform dot position. We're adding to it plus equals vector3 dot up times our move speed times time dot delta time. We don't want move limit, we want move speed. So what this code is doing is it's saying if we're pressing up and we haven't moved up beyond our move limit away from our start position, move us up. And we want to do it using our move speed smoothed out using time.delta time. And then we could also go ahead and put down while we're at it. So we're going to copy that and say down. And then we want to say if our position is greater than our start position minus our move limit. And then down here, instead of up, we'll use down. So let's jump back out into Unity and see if that works. We should be able to move up and down using the W and S keys. Up, down. It's only letting us move as far as our move limit is. And we could play around with those values if we want to move. If we want to let them move farther up and down, we could do that. And I'm also going to change his start position a little bit. I think I want his start position, instead of being 0, 0, 0, I think I'm going to want to move him back something like -6 and still 0. So we're at 0 on the Y, -6 on the X. Let's go ahead and implement the movement for forward and back. It's going to be very, very similar to what you just saw. So we'll go back into our player movement script. And I'm just going to copy all this. And I'm going to paste it. Oops. I'm going to paste it. And we're going to change a few things here. We're going to look for forward. And then we're going to be checking to see if we can move forward, which the rule for can move forward obviously is that we're pressing forward, and we want to check our X position and see if it's less than our start position dot X plus our move limit. And if it is, then we're going to move vector3 dot right times our move speed and time that delta time. And then for back, we're going to do just the opposite. We're going to say X is less than start position dot X minus the move limit, and then we're going to move left. So if we jump back out in the Unity, we should be able to move left and right as well as up and down. So there's, oops, I'm not moving backwards. I moved up, I moved down, I moved forward, but I'm not moving left. So I need to go look at the logic for why I'm not able to move left. So if we're pressing the back key, which if we go look at our input configuration, back is the A key, so that's definitely correct. So if we're pressing the A key and our X position, we want to move back if our X position is greater than our start position dot X. There we go. Simple little typo. If we go back into Unity, we should be able to move backwards as well as forwards. forward, backwards, up, down. All right, so we got our player movement working. Now, before we go ahead and add our orbiter, I want to go into our player movement script, and I want to do a little bit of cleanup. So I like to name things explicitly. So if I come in and look at this code 6 months from now, I've got to use some mental energy to say, okay, what am I doing here? I'm saying if I'm pressing the up key and if my position is less, that's saying if I'm lower than my maximum. Sorry, that's a lot of mental energy that I have to expend in order to figure out what this code is doing. I can make this code a lot more readable. For one thing, this whole block of code can be extracted. So I'm hitting Control-Shift-R. Oh, it's not what I wanted. Let me highlight this and right-click. Rider will give me a refactor menu. So it's Control-Shift-R. I'm not sure what it is in Visual Studio, but you might be able to do something similar in Visual Studio. But I'm going to refactor this. I'm going to actually extract this method. And I'm going to call this handle up movement. Now that whole block of code is moved out of here into a handle up movement. So now Control-Shift-R, extract method, handle down movement. Control-Shift-R, handle forward movement. And do the same thing here, handle backward movement. So now if I come and look at this function, I can tell immediately, oh, I'm handling up movement, down movement, forward movement, and back movement. That takes like no mental energy to figure out what this update function is doing. But you know what? These can be made a lot clearer too. For instance, this if statement here, I can actually refactor this. So I'm going to come in here and say refactor, and I'm going to extract this. Let me see, refactor extract method. I want to actually extract it as a property. And I want to call this can move backwards. All right, so this says if can move backwards, move backwards. Suddenly now, this function is very easy to read. If I can move backwards, move backwards. All right, so let's look at can move backwards. Where did it put it? It put it down here. I'm going to actually move this up. In Rider, I can Control-Shift-Alt and use the up arrow to move that up. So now it's up here above my functions. So this is just an expression body method that checks to see if I'm pressing the back key and if I'm not behind my start position minus my move limit. So that's just an example of how you can refactor your code to make it a lot easier to read. So for instance, I'm going to come into this guy here, Control-Shift-R, extract property, can move forward, and then I'm going to take this whole block of code and call it move forward. So making this code so much easier to read. Control-Shift-R to move this all up to the top. And I can do the same thing for these. Can move down, move down. And one more. Can move up, move up. And just find that little property here. Control-Shift-R or Control-Alt-Shift up. There. Much cleaner, more readable code that I don't need to expend a whole bunch of mental energy to figure out what I'm doing. Let's just go back into Unity and make sure it still works. I can move forward, I can move back, I can move up, I can move down. Great, let's get them shooting. In order to be able to shoot, we need something to shoot. We need a projectile. So let's right-click here, create empty, and we're going to call this player projectile. And we want some art to put on that guy. So let's open our art folder and look at this spreadsheet here and find something that looks like it would be a good projectile. I think this looks pretty good here. So I'm going to drag this onto here, and we're going to put this on the player projectiles layer, and we're going to say order in layer is 2. Ooh, I like that. One thing I want to do though is I want to make him longer than he is wider. Yeah, that looks pretty cool. It looks like he should shoot 2 of those, doesn't it? Looks like he's got 2 barrels here. One thing I want to do is on our player, I want to add a shooter object, which is basically the barrel. In fact, I'll call it launcher. I'm going to call that launcher. And if we go to our scene view and we double click, zoom in a little bit, I want to position that guy right in front of the barrel, like so. And then I'm going to duplicate that. And let me just get rid of that. And make this negative. Well, maybe I'll move that down just a little bit more. All right, now if I was to drag our player projectile onto there, why am I not seeing anything? Oh, I need to zero this guy out. There we go. All right, so I don't really like where that's positioned. So let's move our launcher forward and up a little bit. And then we're going to do the same thing. I'm going to just cut that, paste this child. Oh, I don't want to do that. I want to take our launcher, move that forward, move that up. That looks pretty good. I do want to make him a little bit thinner, I think. So let me go ahead and move this guy here, 0.5. That looks pretty good. So what I'm going to do is I'm going to create a prefab from this guy here. I'm going to go into our assets folder. I'm going to right click, create, folder, prefabs, double click, and I'm going to drag this player projectile into there. And then I'm going to delete it from here. All right, so our player ship has 2 launchers. And we're going to want to add a script to this projectile. So here under scripts, right click, create player projectile. I'm just going to call it projectile. Rename this projectile. And then I'll double click that. I need to rename this. The file name has to match the class name for mono behaviors. Okay, so in our projectile script, we're going to want to have a serialized field for our speed and for our duration. And for our speed, I don't know what I want that to be. Let's make the speed 10. And we'll make the duration 3. So that's how many seconds it'll live. Okay, so we've got our speed, we've got our duration. We're going to have a variable here called end time. And when this thing is first enabled, we are going to set its end time to be time.time plus our duration. Now in update, we want to say if time.time is greater than or equal to end time, then we want to destroy the game object and return. Otherwise, we want to move this guy. So we're going to say transform.position plus equals transform.right times speed times time.delta time. So this should move the projectile along what it considers to be forward, which is right in a 2D game, at whatever speed we've set here, smoothed out by time.delta time. Okay, we're also going to want to create a script for our launcher. Let's go back into Unity here. And before we do that, let's go to our prefab for our player projectile, and we'll say add component projectile. I could just as easily have dragged the script on there, but it accomplishes the same thing. Now for our launcher, go into our scripts, launcher. double click that. And what do we want to do in our launcher? We want some serialized fields. We don't need our transform. So we're going to go ahead and delete all this. We're going to want a game object to be our projectile prefab. We want to have the fire delay. Now, if I'm being consistent, I would put the fire key in that input configuration, but I'm not going to be consistent. I'm just going to put that here. Maybe the orbiter might have a different fire key. It's not, but I'm just saying if I wanted to, I could do it that way. So I'm going to say keycode.space. It's going to be the fire key. We're going to have a fire time. And I want to have a Boolean that says whether or not I can fire. And it's going to be an expression body method. We're going to say if time.time is greater than or equal to our fire time, then we can fire. And in onEnable, we're going to set fire time to be time.time plus our fire delay. And in update, we want to say if not can fire, just return. Oops. If not can fire, return. Otherwise, if input.getKeyDown, fire key, fire projectile, and I'm going to hit Alt-Enter to create that function. And all we're going to do in here is reset our fire time. And then we're going to instantiate the projectile prefab at our position. I didn't cache the transform, so I'm going to access it directly off of this object. And we don't really care about the rotation because our ship doesn't rotate. So that's it. That's all we need to be able to fire a projectile. I'm going to delete these extra using statements and go back out into Unity. I'm going to select both of my launchers. And I'm going to drag that launcher script onto them. And then for our projectile prefab, we'll go into prefabs, and I would just drag that right there. Now, if I did all this right, when I hit play, I should be able to shoot projectiles out of both barrels. And I can't spam fire because I've got that fire delay. I think that looks pretty good. Okay, so we've got our ship firing. The next step will be to add our companion orbiter ship. It's time to start working on our orbiter. So what I'm going to basically do is copy the player, and I'm going to just change a few things. So if we take our player here, and I just hit Control-D to duplicate, and I'm going to rename this to orbiter. All right. One thing we want to do is here for our sprite, we're going to use a different sprite. So we were using this guy for our ship, so let's use this guy. Maybe this guy. So I'm going to drag that in there. So now we've got a little bit different image there. He's going to have his own launchers, but we're going to create different projectiles for him. We may have to go and edit their position later when we actually get them to shoot. Right now that looks fine. One thing we're definitely going to want to do is we want the orbiter to be a child of the player, and we're going to adjust his relative position to the player based on where the player is moving so that he orbits the player. He moves in front of the player, behind the player, above the player, and below the player. And of course that will all be done via a script. But for now, let's go ahead and create, we might as well go ahead and create the projectiles for him. So if we go into our prefabs and we duplicate this, we're going to take the copy and we're just going to rename that to orbiter projectile. And it's pretty much going to be the same, except the sprite is going to be a little bit different. So instead of this blue sprite, let's go into our art folder. I'm going to use this red one. That's not exactly what I wanted to do. I'll select that and then drag this red one into there. So now we got a little bit different looking projectile for the orbiter than we have for the player. And then we're going to take this guy and we're going to drag him onto the player. And I'm just going to move him behind the player 2 units. So there we go. The orbiter is trailing the player. That's a little bit much. Let's make him negative 1.5. I think that looks a little bit better. And we're going to get rid of this player movement script from the orbiter. We're going to give him a new script, all his own. We're going to call it orbiter. So right click, C# script. And why did it not create the script? Create C# script. There we go. Orbiter. And double click that to open it up in the editor. It sure is taking its own sweet time. Okay, so let's add some serialized fields for this guy. We're going to want some floats. We want to have a move limit, kind of like we did for the player. And we'll set that to 2F. And we want to give him move speed. And we want this to be a little bit, I think we want this to be faster than the player ship. The reason is we want him to whip around the player. Like the player moves forward, we want him to whip behind the player. And if the player moves back, we want him to whip around to the front of the player. And if he moves up, we want him to whip down below the player and so forth. So let's go ahead and set that to 15. I might play with those numbers. Once again, we're going to want our input configuration. So here, we are going to say, and we're going to cache our transform. Yeah, we'll go ahead and cache the transform. So we're going to grab our input configuration by using find object of type, input configuration, true, alt enter, create field. Okay, so we've got that. Now we're going to handle movement pretty much the same way that we did for the player, but it's going to be the opposite of the player. And we're going to also use those properties like we did to make it more readable, but I'm going to do that from the beginning. So first of all, let's say, should we move forward? Should move forward. And a condition for that is going to be that the player is pressing the backwards key. So it's going to be the opposite. And our transform.localPosition.x is less than our move limit. So basically, we want to move relative to the player, whatever our move limit is. And we want to move the opposite direction the player is moving. So if the player is moving back, we want to move around in front of the player. And then should move backwards, we'll say input.getKey, inputconfig.forward, and our transform.localPosition.x is less than our move limit. Is that right? Nope, greater than our move limit. Let me think about this for a second. Now, actually what I want to check is if we're greater than our negative move limit. Because our move limit is how far either direction we can move. We're moving relative to the player's position. So if we're moving backwards, then we're actually moving negative related to the player. So we want to move as far as negative our move limit. So if our move limit is 2, we want to move as far back as -2, but no farther. Okay, let's just test move forward and move back, and then we can go add the others later. So the way we'll do that is in update, we're going to say handle forward movement and handle backwards movement. So we'll create that function and we'll create that function. So let's do forward first. So if should move forward, move forward. And move forward is going to simply be transform.localPosition. We're going to add vector3.right, and we're going to multiply that by our move speed times time.delta time. Okay. And this actually needs to be there. And we need to do the same thing for handle backwards movement. So we want to say if should move backwards, and we'll go ahead and create that. And I'm going to copy this. The only difference is we're going to do vector 3.left. All right, let's go ahead and jump out into Unity and see how that looks. If we give it a test, we should see our orbiter zip around in front of and behind the player as the player moves forward and backwards. Let's just look at him. We need to add the orbiter mover to him, the orbiter class. All right. All right, so if I move forward, so you can see he's maintaining a relative position to the player as the player moves forward. Now we just need to do the same thing for up and down. I think, though, we want his move limit to be 1.5 to match the distance or his starting position relative behind the player. So let's handle the up and down movement now. So double click to go back into the orbiter, zoom out just a little bit. That's zoomed in a little too much, I think. And we've got handle forward movement, handle backwards movement. Let's add handle, don't want to call it down, call it down movement, and handle up movement. Alt enter, create method, and alt enter, create method. Okay, so how do we want to handle up movement? First of all, if should move up, move up. Oops. Need to hit escape so it doesn't auto-complete. All right, so we're going to alt enter, refactor this. Actually, how do I want to do that? Control Shift R. All right, I'm just going to come up here and say bool should move up. And it's going to be, I'm going to have to check our input like before. Say input.getKey, input config. And remember, we're going opposite now. So if they're moving down, and our transform.localPosition.y is less than our move limit. Okay, and now for this, alt enter, create method. In order to move up, we're going to say transform.localPosition plus equals vector 3.up times move speed times time.delta time. This should be an equal, plus equal. All right. And for handle down movement, let's come up here and let's just copy this and rename this to should move down. So in this case, if the player is moving up, and our condition is going to be that our local position.y is greater than our negative move limit. Okay, so down here under handle down movement, if should move down, always forget to hit escape, alt enter, create method, and so to move down, transform.localPosition plus equals vector 3.down times move speed times time.delta time. Jump back out into Unity. Give this a good old college try. All right, I'm thinking I'm liking that. It might not be exactly like what I saw in the video, and we could play around with those values a little bit, like the move limit, the move speed, and that sort of thing, but that is close. The orbiter definitely goes in front of the ship, behind the ship, above the ship, below the ship. We could probably put in some stuff in there to try and even them out a little bit to keep them closer on line. That would be pretty easy to do. But I can leave that to your imagination. How about if I shoot? They're both shooting. But we need to change the projectile for the orbiter. So let's go ahead and do that. So if we look at our prefabs here, we've got our orbiter projectile. So we just need to select our launchers here and then drag in that orbiter projectile into there. Control S to save. And let's see how that looks. And there we go. Okay. I'm thinking that's looking pretty good. So let's add a little something for the player to fly past. I'm going to create an empty game object here and call it boss. And go into our art folder and drag this boss sprite onto there. And we're going to create a layer for it. Call it enemy or enemies. Select him again and then assign him to that layer and say yes to children. And we're going to change his order and layer to 2. There we go. We're going to want to rotate him so that he's facing the player. And let's bump his scale up a little bit. And I'm going to move him up to about 2. And then I'm going to duplicate him. Actually, I don't want the sprite to be moved. So let me set that to 0. And we're going to move this sprite to be 2. Move the object to be 2. And then we're going to duplicate this guy and put him at -2. So there's a couple of them. All right. And let's select both of these guys. Look at our scripts folder and put the orbiter script on them. And if we look at our background sprite, our scroll speed is 0.75. Let's make these guys scroll a little bit faster. Actually, I can't use background scroller because that's using a texture. That's trying to scroll a texture. What we actually want to do is move this object at a scroll speed. So we have to add a new script here. We'll call create C# script and we'll say scroll objects. For lack of a better name, we'll put that on the parent object here as soon as Unity gets done recompiling. And double click that, add a serialized field for move speed. And I'm going to default this to 0.8. So it moves a little bit faster than the background. This should add a nice parallax effect. And all we're going to do in here is we're going to say transform.position plus equals move speed. Or we want to go left. So vector 3.left times move speed times time.delta time. And I believe Unity or Writer is going to suggest that we put those in parentheses. Okay. All right. Get rid of this unnecessary using statement. Jump back out into Unity. And let's just move these guys off the screen a little bit. So we'll set their X position to be something like 5. And now they should scroll into view. Oh, but they're moving. They should not be moving. Oh, you know what? I put the orbiter script on them. Oh, my. Yes, we want to remove the orbiter from them. Why did I do that? Yeah, you just want to scroll objects on them. Okay. Sorry for the confusion, folks. There we go. And so they are moving past, but not nearly as fast as the background. So we need to increase that move speed. Let's start that over. Not quite that fast. So let's try this about 4. Nah, they're moving slower than the background. We want them to move faster. And put them off a little bit farther. Make that about a 5. That is still moving slower than the background. Let me just slow the background down some. They're moving the same as the background. All right, so let's make these guys a little bit faster again. That's better. It gives you a little bit of a parallax effect. Well, I think that about covers it for this video. If you enjoyed it, and I hope you did, do me a favor and click that like and subscribe button. And click that notification icon too, so you can be alerted the next time I post a video or go live. And I know I didn't take this game as far as we could have taken it. There's a whole lot more we could have done. We could add some colliders and have the enemy ships shoot back. We could have done a whole lot more, add some different space structures and things. But I'll leave that to your imagination to fill in. If there is anything that you would like to see me cover that I didn't, or if you have any questions or suggestions, drop a comment down below and I'll get back to you as soon as I can. And also check out my Discord channel. I'll put a link in the description. That's a good place to go if you want to ask a more detailed technical question. So, thanks so much for watching and good luck on your game development journey.